Thank you so much for checking out this presentation. We are going to be talking about an open source tool and research that Andi and I did called Cloud Console Cartographer. Tapping into mapping is greater than slogging through logging. I'll do a brief introduction, talking about some different aspects of event logs, and then we'll shift to looking at cloud logs and some of the ways that they're different from more traditional on-prem, host-based, or network logs. And then we're going to really expose the problem of noisy logs, particularly in specific cloud vendors' UI management consoles, and then the problem that poses defenders, incident responders, threat hunters, et cetera, from making sense of what the actual input action was to produce a plethora of those event logs. Then we'll look at the solution, which is all the details we implemented in this tool to make sense of these noisy logs, and then we'll end with a tool demo.
Good afternoon, everyone. Short presentation about me. My name is Andi Ahmeti. I'm from Kosovo. I started the journey of cybersecurity at Permiso as an associate threat researcher almost a year ago. And during this time, I've developed an open source detection framework tool, which is called CloudTrail. Also, a big Lakers fan. Good.
And my name is Daniel Bohannon. I'm a principal threat researcher with Permiso Security. We're a cloud-based detection and response startup company based in the US. I've been a defender my whole life. I have quite an obsession with obfuscation and evasion research, so a lot of people assume I have a lot of offensive experience. I actually don't, but I really love the time I've spent with red teamers at my time at Mandiant. And yeah, this is a really special conference. And so if this is your first time here, then this is my third time. And I really appreciate it more and more as I travel and do conference presentations around the world. There's something really special about this conference in the warmness of the people and the conversations that you have. And I feel like there's just a really healthy respect of red and blue that a lot of times egos get in the way when conversations are flying around on Twitter. And it's really nice to look at a human face-to-face and admire and appreciate the tradecraft and the thought processes that go into being creative in offensive security, defensive security, because ultimately it's human creativity, and it's just quite a cool opportunity to learn that from one another. I'm a huge coffee fan. I also like motorcycles. I do not own one of these motorcycles, but boy, did they look fun. And yeah, I have really love open source tools. Again, I have quite an obsession with obfuscation, and there's a couple of the tools listed there, but really excited to be here today. So as a defender, logs are extremely important. They're facts. They give us information. They tell us things that have happened. Sometimes the absence of logs is also a problem as well. And so we want to make sure that we're not using logs incorrectly. But ultimately, it's visibility. Another thing is we should make sure that we understand what logs are available and turn them on. Attackers typically do not do this for you. So as a defender, you should do that yourself. And also understand all the steps that can go wrong with those logs being potentially deleted, intentionally or unintentionally, by either an attacker or someone in your organization. And lastly, do something with the logs. It's not as beneficial to have the logs and not do anything with them. It is helpful if you're doing an investigation, but wouldn't it be great to detect that activity before having to go back in time a few weeks or months to investigate an intrusion that happened? I want to talk a little bit about some of the differences between cloud logs and more on-prem logs. And I'm speaking less of where the logs are stored and more of the source of the logs. A lot of my experience has been in host-based security, and so those logs are extremely detailed. You also have a lot of kind of aftermarket logging options like sysmon. We've heard some different talks about using ETW, but there is so much detail in these logs. All the image loads, all the process creations, arguments, threads, call stacks, even all the way down to file content. We can actually start to extract attacker information from the endpoint to see what are they working with in their attack. So there's a lot of fingerprints that exist based on the attacker's activity. And one of the things I love about forensics and IR is you're discovering fingerprints that often the attacker did not intentionally create and maybe is not even aware of. Cloud logs are very different. They are much less granular and abstracted because you're essentially looking at API calls. and they're determined by the cloud provider. There's not sysmon add-ons for you to do. There's quite a lot fewer opportunities to enrich those logs natively. It all depends on what you can do with them after the fact. We kind of break the logs up into control plane and data plane. Control plane is typically enabled, and that is the changes to the configurations for the cloud provider. Data plane is typically not enabled. It's the usage of these things, and it's usually not enabled because of the sheer volume and cost associated with storing and maintaining those logs. So an example of control plane would be making some S3 bucket or Azure Storage Blob configuration change, and then every single request for objects in those places would be data plane logs. There's also delays in log generation depending on the cloud provider. Sometimes it's a few tens of seconds. Sometimes it's 15, 20, 30 minutes. So these are also factors to consider when you're looking at detection and response. Retention limits is another thing as well that we'll talk about in the next slide. But overall, these logs are just, they're not quite as detailed, and you have to create fingerprints by joining together multiple events and kind of create your own distinct patterns. So finding patterns across these logs is really, really important when it comes to threat hunting and detections. So what do cloud logs actually look like? If you haven't checked it out before, this is a really simple example of just adding a user. And so on the left, we have an AWS example. On the right, we have an Azure log example. There are quite a few differences between different cloud providers. So normalization becomes quite important if you are in a multi-cloud situation. But a lot of the same information is there. Now, how do you get those logs? Well, you can query based on the API that the log provider gives you. And there's a couple pros and cons related to that. One of the pros is it's the least delayed. As soon as that log is available, then when you query it via the API, you get that information. One of the cons, though, is that there are retention limits. AWS CloudTrail logs, you have a 90-day retention limit. If you're trying to get something that's 90 days and 1 minute old, it's gone forever. Azure is only 30 days. So would you be comfortable knowing you only had 30 days or only had 90 days of data? If that makes you uncomfortable, then you should consider not just relying on the API, but forwarding those logs to a secondary location. There's a lot of good reasons to do this, but it allows you to store very cheaply a lot longer retention for those logs. You also don't have to deal with API throttling. So for example, in AWS CloudTrail, you can only call that lookup events API 2 times per second. Now that sounds like a pretty reasonable number, and it is in most cases, but that's globally. So if you have 10 different security products all querying those logs in the same way, you can hit API throttling really quickly, and it affects everyone else trying to use that same API. So forwarding to a secondary location allows you to avoid the API throttling scenario. Easier consumption by other tools is another good reason. But some of the cons, sometimes there's actually data differences between the forwarded event and the event from the API. An example of that is in AWS CloudTrail logs. If you do lookup events, then there's actually an entire different section called resources, and it's reference resources for that event. So it can be usernames, access keys, a lot of different items. But if you forward that log to an S3 bucket, that whole section's completely gone. It's not even there. So as defenders, it's always, always, always important to know your data, test your tools, and look at the differences between retrieving that information. So the tool we're going to talk about today and everything we're looking at is the interactive cloud console usage. Now the word console is kind of problematic here because typically we think black terminal window, but AWS actually calls their web UI the AWS Management Console. Azure calls there's the portal. But so when we're referring to the word console in this presentation, we're referring to this web browser portal. So do attackers actually use this? Like how many attackers are using the UI? Quite a few actually. Some attackers are also new to cloud. They're figuring it out as they go, but they're being darn successful at it. And maybe their playbooks are actually just PDFs saying, click here, do this. And they haven't really had the need to script out these things. 2 threat actors that we track, Lucre 1 and Lucre 3. Lucre 3 is also known as Scattered Spider. There are many examples in which we see them using the console to do different tasks. Recon tasks, exfiltration tasks, et cetera. And then sometimes there's also technical reasons why an attacker might use the console. We had an incident that we were responding to last year where an attacker had an ECS container breakout. And it was a federated token. And what's interesting is that a federated token is not allowed to access the IAM service, but in the AWS documentation, that limitation doesn't apply to console sessions. So that's the very first thing they did, was pop up in a console session, create a user, and go on with their attack.
Cool. So we saw 2 cloud logs examples, and let's switch the focus and actually checking the log volume perspective. And for that, we're going to do some enumeration steps in AWS. And by enumeration, I mean just clicking around something that is not changing or updating anything. For example, listing user, listing roles, whatever which is related to a read-only event. And surprisingly, we see that AWS is quite noisy in that perspective. And being honest, that's one of the main reasons why we are here today, trying to solve this problem. Azure, on the other hand, they tend to do things differently. And when I'm speaking about Azure, I'm speaking about the Azure portal. So if you're trying to do some same enumeration steps, like listing users, blobs, containers, we don't get that, because Azure, again, logs only update or change event. So doing this enumeration clicks, we're pretty much muted, and there's no logs generated at all. And for that, Azure kind of gets a free pass from our problem, not because they are doing a better job at this, but since they don't even offer enough logs for us. So being as a security person, you'll always want to know if an attacker is enumerating your resources. And with that being said, we're going to focus only on the AWS service, where we get that kind of noise, so we can have a solution for that problem. Switching back to the main part of the presentation, which is the problem, and that's the noisy console logs. So being a researcher, you understand 2 things, and you love 2 things, and that's good coffee and also logs. But sometimes having too much of both of these can leave you out in the dark, you know what I mean? And the problem here is most of the time, you're out in the dark because of the absence of logs. But in our case, it's actually the sheer volume of logs that is going on here. And sometimes it feels just like playing the Atari Super Breakout game, where we can think that little ball, which is hit from the paddle, as one user click, and it goes to the top. Maybe it hits just one little square, and that could be like one correlation, one click, one request. But that's obviously not always the case. And if you play this game, you know that sometimes the ball can get way over to the top and hit tens, maybe hundreds of squares, and they can be represented as one click, which calls tens or maybe hundreds of APIs in the backend. And we're going to see that that's actually the case in some of our sessions that we are going to present later on.
It's definitely the case. Oh, check, check. It's definitely the case that we don't want the high score when it comes to these logs. What we'd expect to see is one input event in the UI and one log. That would be the easiest scenario for a defender. So the way that we kind of started to enumerate this was we created an IAM user and gave it absolutely no permissions, just a login profile, and just started clicking through the console. And if you do this, you'll start to see a lot of these tiles start to have these errors saying you don't have access to run this API and this API. So if we, for example, go to the IAM service, then we'll see even more errors and kind of starting to enumerate, okay, if I were to click on IAM, what are all the API calls it's trying to do? And maybe, let's go a little further and click on users and see, yep, there's another one there, IAM list users. So if we're trying to map that click to know when an attacker or a user clicks on that, then what would all the events be related to this? Well, let's actually give ourselves access to run this event and see if anything else happens. So we can do this just with a little inline policy. Now when we click that, we actually can see we have 3 users here, but now we have even more errors, and in fact, those errors are different API calls. So if we kind of focus on this example, then how do we go about mapping and documenting what are all the API calls related to this click?
Cool. So looking through data can be a pain in the back sometimes, but we have some tips for you. So if you open the hood, we can see some treasure inside of it, and these are the 4 golden rules that helped us very much. The first one is having full permission, since you don't want to be losing time and giving yourself manual permission every time you're trying to do something. Is having a new environment for each service. Lots of Excel spreadsheets where we track the time of our action, and Debo's favorite one, which is becoming mine too, lots of coffee or any coffee and drink of your choice. Let's switch back to the data creation. We have 3 scenarios where we are running the list user action. And the difference between these are scenario A has no permission at all, so our user can only log into the profile but not do anything at all. Scenario B is where we gave our user explicit and manual permission to only have the list user action. And scenario C, where our user has everything, so he has full permission. Let's see what events are generated for each scenario. So for scenario A, we can see that we have only 1 log generated, and that's the IAM list user, and it was denied due to obvious reasons. Moving down to scenario B, we see something change. We see that the first action was indeed successful, and we have another 5 grouping of events which were denied, but they happened. In scenario C, we see some difference. We see that the 5 grouping of events that we saw also in the previous scenario are now successful, and they occurred once per identity. If we check the request parameters, we can see that they are 3 IAM users. So knowing that, we're going to keep this 5 grouping of events to our little map to the side, and let's focus down to the last 2 button events, which are the main difference. And we see that it's the get access key lost use event. And what's interesting about this is that they are being called only because there are 2 access keys present in between these 3 IAM users. But we know that the user may contain 0 up to 2 access keys, but that 0 means something, and it means that they may have none, and this event might never occur. So our solution is, let's group these events in 3 categories, and the first one is the anchor event, or the main event, the required events, and also the optional events, which are, again, events that may happen, but if not, it's not that they'll be a deal breaker for us.
So if we look at these optional events, we kind of categorize it into two groupings. The first one we're just going to call background events, because they just happen in the background and truly are not related to any input action. So for example, if you just log into AWS Console, you'll be presented with a console home, and we can see all these blue events are just background events. If you were to walk away and take a 2-hour coffee break, those events would kind of keep popping off every couple of minutes. And so what we do was you basically try to separate these so that when we're writing definitions for the mappings, we're truly only looking at the events that are related to that mapping. So we basically group all these events just so we can slide them out of the way and not have to deal with them anymore, so that we can focus on what's left, what truly is going to tell us the input action. The other kind of optional event is based on context. And this is one of the trickiest things for us to learn kind of the hard way, and how to redo a lot of mapping, because everything is connected. The more kinds of resources you have or configurations you have for any kind of object will then create new events based on different clicks. And so this is why we basically try to reset our mappings to start with absolutely nothing to get the core fundamentals, and then go and add additional context. But to demonstrate this, we're going to create 2 identities. The everything bagel, which is going to have everything we can think of, all the access and permissions and everything else, and then the plain bagel. So when I say everything, I mean everything. This IAM user has lots of attached policies, which are managed policies, a permissions boundary. It's part of a group that also has policies, so those are inherited. We added tags. From a credential perspective, it has a login profile. We added a virtual MFA device. It has 2 access keys, both of which are active. SSH public keys, and on and on and on. Again, anything we could think of that AWS allowed us to add to it, we did. And the plain bagel has literally nothing, not even a login profile. So now, if we were to click into each of these IAM users in different tabs, then how would those events look different? So if we clicked on the permissions tab for the plain bagel, we can see this listing of events. And if we click on it with the everything bagel, we see a few more events. Now, before we go and look at these comparisons, I do kind of want to draw your attention even to the same API call. AWS is actually using two different user agent strings for the same access keys that are here. There is incredible diversity in the user agents and almost like the coding style between different AWS services that you can see the more that you spend time in these logs. And it makes sense. There are different teams of humans at AWS doing these different services, so there will be some differences that you see. But keep that in mind. There's a lot of different ways that we try to normalize some of these values to make it simpler to write the kind of signal mapping logic for this. But comparing the everything in plain bagel, we can group these into a few different buckets. Everything in green, common events. And not only common events, but common request parameters, common user agent strings. Everything is identical. And then the yellow and purple, we do see some differences there. Let's go on one more tab. If we were to click on the security credentials tab, we'll see, again, a pretty similar grouping of most of those events are going to be common between the two. But in the purple box, we see there are a few differences. One really cool thing here is you'll notice this get access key last used pops up quite a bit. All of these logs, like it's important for us to group all these logs to say this one input action produced these logs. But if you kind of pause for a second, if you're an incident responder and someone just exported these logs and gave them to you, not only can you map it and say this is the input action, but there's a lot of information in there that tells you about the environment state at that time. For example, these are the 3 IAM users that were active at that time and that showed up on the screen when the person clicked this. These are the access keys that were present and active at that time. And so when we've done investigations, it makes sense why the attacker clicked on this specific user, because when you see the list of 10 or 20 users that were there, of course they'd click on the one that has the word security in it, given all the other users that were there. So there's a lot of context that you can see from these logs, and in the tool that we wrote, we designed it to extract that information and to present it in as usable a format as possible.
Thank you, Debo. So we saw some events that were happening, and now let's just take a step back and see what would be the difference between running some of these events from 3 perspectives. And by perspective, I mean first running them through the AWS CLI, the Boto3, and last in the web console from a browser. Now, let's see what actions am I talking about. We have 3 ish, and the first one is creating a user, creating an access key for that user, and lastly, attaching a user policy. Now, moving down to see what events are generated for each of these actions, we are not surprised. We're expecting 3 output events from the 3 input events that we did, totally fine. Same small difference in between them, that we can see that the event source and the event name is appended at the back of each user agent. So 3 input events, 3 output events, very nice, very clean. Moving down to the Boto3 SDK, we have the same actions. We are creating a user, creating an access key, and attaching a user policy to this user. Again, 3 output events with a small difference between them. And that actually is not a small difference. They have no difference at all. The user agent is the same across them. Now, if we move down to the console, now we're going to do a roadmap between each user click that an actual user needs to make in order to recreate the same 3 steps. Now, let's see what the first one is: the console home, or the home page that we get redirected once we are logged in. And for that, we have 13 logs generated in CloudTrail. Now let's keep that to the side, and we can keep track of the number. We have 1 event generated for just clicking the search bar, and 8 events generated after clicking the IAM service icon. So we have 9 events. Going down to the IAM users, 18 events, and we're going to talk later about the worst case scenario for this specific click. So 18 events would sound like a pretty good scenario. Moving further down, now we are starting the to recreate the first step, and that's the user creation. And we'll hit the create user button for events. Again, attaching a user policy to that user, which has 15 events. Moving further down, we have the last step, finally, which is creating a user, which accounts for 3 events. And immediately, as you can see from the chain, we get redirected to the permission tab of that user. And we have 13 events totally. Create access key, surprisingly, only 1 event. That's cool. Speaking from the user agent perspective, we see a variety of them, like only 10 events generated from our actual browser. And the other user browser consists of AWS internals, Java versions of user agents, and also some health, which were mentioned as optional events. 73 events from the 9 clicks that we have. So again, in comparison, 3 input events and 3 output events for both AWS CLI and Boto3, and only 73 events only. Yeah, for this for the console. And if that doesn't sound much, wait till the next slide. So we thought it would be interesting to come up with a mathematical formula so we could kind of predict how many events will be generated for this particular click. So we have the 1, which is a constant, and represents the anchor event. We have 5 times n, where n will be the number of available IAM users. And lastly, we have the get access key last used, which again, a user may contain 0 up to 2 access keys. So in our case, we had only 2. Now, let's increase that number a bit. If we have available 20 IAM user and hit the list users button, we'll have 141 events. And if we keep increasing that number to 50, we'll have 351 events. And if we have 100 available IAM user, we'll get 701 event generated from only that click. Same approach came for the S3 service, where for 100 available S3 buckets, we'll get 421 events generated.
In this research, we were kind of hoping there'd be some shortcuts we could find, like Andi mentioned. However, looking at the user agents, like even the consistency of the user agent string showing up as Mozilla, as coming from the web browser, the events that were present really didn't tell the story. You know, when the events are create user or create access key, like yeah, those are pretty self-explanatory if you see those in a mix of events. But there's a lot of clicks that don't have any explicit APIs that really make sense for what's happening there. So ultimately, what we're doing is trying to aggregate this data. After we manually map it, we're trying to define all these individual events so we can say in summation, these are the events related to clicking this IAM users button. These are the events related to clicking the create user button. This is the event for creating that access key. And all along, as much as we can, let's identify those background events and get them out of the way because it's not directly related to an input action from the user. So that's the problem. Now, the solution. How do we actually go about technically solving this? Well, as Andi mentioned, we break everything up into anchor events, required events, and optional events. We kind of take a 2-pass approach across all the events we're ingesting. One pass is adding labels. The second pass is doing signals. And so when we want to define a signal for IAM users, we take the same exact construct of anchor, required, and optional, and it's directly related to the actual signal class that we have. So you're defining not only these events, but also metadata about the event. Think of this like an alert name, an alert description, to basically say, if this occurs in your logs, what should be presented to you as the analyst. How would you describe this action? What would the URL be? And what you'll notice is that there's also placeholders in here for updating the content. And so again, if you click IAM users and there's 20 users present, when that signal is generated, you'll actually see the number 20. You'll see the 20 users. You'll see any access keys that are present, both in the description as well as in an additional data object that contains programmatically accessible details from that event. So the first pass is adding labels. So we're looking at each individual event. We're looking at all the details like request and response parameters, user agent, service name, event name, and then we're adding one or more labels to that event. So if the event comes in and it matches all these criteria, then these are all the labels that are added in this specific order. ordering has become such an important thing the more that we've done this mapping, and there are several different levels of ordering that we have to keep in mind. The second pass then says, okay, we've gone through all the events one by one. We've added the label or labels to each event, if there are any. And now we're going to go back. And remember how we talked about there's anchor events? Well, if I go back one slide, if any one of these signal definitions said, by the way, list users as an anchor event, then there's a Boolean flag that'll be set to true. So in the second pass, as we go through event by event, whenever we reach an anchor event, we stop. And then we look at the list of labels applied to that event, and we go down the line and say, for this first label, look behind X seconds, look ahead X seconds, and retrieve all the events that also have that same label applied. And then take that together, summarize that, and then say, does this match the required signal definition for this mapping? If yes, awesome. Update all the flags to say these are now all contributing to the signal and move on. If not, then go to the next label and the next one and the next one and do that evaluation before and ahead. And the last thing I'll say before we actually do a demo here is we do this not just to pull the events together, but also to extract the data out of it, as I mentioned before. There are a lot of really complicated tricks that we had to come up with to accommodate some very interesting situations. For example, like if you're creating a user or certain properties you're adding to a user, then there could be 4 or 5 steps in that process. Well, the first process might have an event that says this is the username that we're modifying, but maybe the third and fourth steps don't. It might just be 1 or 2 events, but none of those events actually contain the username information. So what we can do is say we're going to fire this signal for this mapping, but by the way, we're going to look at the previous 1, 2, 3 signals, and if those signals start with this, then we know that we can pull that username from previous signals and carry it forward into that mapping. There are also times where we have to merge signals together, and then sometimes where a current signal can be modified by a previous signal, or even where a current signal can say, actually, let's modify the signal before us because we have more information. So like, for example, anytime you expand a policy, there are many places in the AWS console where you can expand a policy. So we can generically say a policy was expanded, but if we know the last couple of signals were us creating a new user, then we can say, hey, this is actually step 1.2 of creating a user, and this policy was expanded. So with that, let's do a little demo. This is the ultimate speed run. This is not fast forwarded at all. We're going to basically pretend like we're an attacker and emulate some techniques that we've seen throughout several investigations. So attacker logs in. They're going to go into the IAM service and enumerate some users. We're going to click on this user called Petula. We're going to click on the permissions tab, security credentials. Actually, let's give ourselves a login profile so that we can log into the console with this identity. So we create that. The next thing, we want to have an access key, but the 2 are already defined. So we have to deactivate one and then delete that key so we can then go and create a new key and get that key material and use that as a form of persistence. So here we are creating this access key. I'm not going to bother clicking on the material there, but that's a step that you would do. So next, let's go and look at Secrets Manager. Attackers like to see what secrets are stored in Secrets Manager, which is like a password vault that AWS provides. And so there's only a couple of secrets here. Let's click on the first one, which is Opnieri, and we'll click on the overview. You can see the actual value that's there. That's cool. But an attacker wants to be a little more efficient, so let's just open up CloudTrail and programmatically run with the AWS CLI or with a Bodo Python script and enumerate all those keys, outputting them to secrets.json. And then we have a very convenient GUI to say, hey, just go download that file. We'll just wait a second for that to download. And if you look on the upper right, we'll see it in just 3, 2, 1. 1, 1, 1. There we go. There's the file. So the download was successful. Let's do a little more enumeration. Let's go and look at S3. As an attacker, I want to know what kind of data might be stored based on bucket names. So again, we're just going to go in and click on a bucket. We're going to click on the FLIA bucket, click a couple tabs, objects, permissions, management, etc., access points, and then let's do one last thing before we actually look at what the logs are producing. This is one of my favorite. This is an EC2. In this account, we have 0 EC2 infrastructure, but if we click on EC2 Global View, there are over 300 events that get produced just by this one click with no resources present. And it's so much that you can actually see it has a progress bar because it's running all these individual checks in all the available regions. So, as defenders, what do we do with this information? Well, if we grab those logs, these logs are actually available in the demo folder of the project. So first, let's do that first pass. Let's add signals, which is going to be the labels and the signal generation. Let's look at the first couple. What's really cool about this is we keep the original event, and then we add an enrichment object, which contains all the signal, or it contains all the labels or potential signals that can be added. So here we had the original event, and then the signal information in that enrichment object. In this case, there's actually no signal that fired. So let's actually choose one where there is an enrichment.signal object. So here's one where we have an actual list users event, and we can see that's when IAM users was clicked. So we have all this information here that we've enriched and said, hey, here's the summary with the number of IAM users, the names, the access keys, and then you can see this additional data down at the bottom where you can programmatically access all that same information. And as I mentioned before, we do access this information in certain look-ahead, look-behind signal scenarios. So this is looking at a really detailed example event by event. The next thing we can do is say, let's do like kind of an event summary. All the green events now are ones that are part of a mapping. And then above those groupings of events, we have the signal information. This view is really helpful when you're trying to debug or add new mappings, because usually what you're doing is saying, I don't see a signal. Why don't I see a signal? What events are not contributing to the signal? So we can just add the event mapping information. So we can see here, now under every event, we have the information like user agent request parameters and, most importantly, the labels that were used for that mapping. So red labels are those that did not successfully map, the before and after events. Green did, and then gray is anything below green that was just skipped if a signal was properly generated. This is still not really the best view for looking at an entire session. This is more for a debugging view. For understanding what actually happened, we're going to do the show session summary. So again, when all the signals are working great, then this is the view from a CLI perspective that's going to make the most sense, where you can see 484 events was that IAM users click. Any values that we extracted, we're highlighting in blue here, so that you can kind of quickly visualize what data was pulled out. And there's that last click we did, 307 events for that global view. But most people don't necessarily want to live in the CLI, so Andi's going to talk about what we did about that.
Yeah, we were really motivated to do some front-end work, and immediately after we started, we saw that it's not that as easy as it looks. But we came up with this UI, which is supported by Dash AG Grid. So we can see that we have 3 buttons at the top where you can see the events that were mapped, unmapped. Also, the table has all the cool AG Grid features like filtering on different cases, switching the column row, also sorting by the columns, and we came up with a cute little search filter with searches all across your data. Yeah.
So with that, what are the main takeaways? Console sessions do matter from a defender's perspective. Attackers do still use them, but more importantly, regular users use them. So being able to filter out and understand benign activity is really important, so that what you're left with is going to be potentially interesting malicious activity. Number 2 is understanding what your log sources are. What are those retention limits? Are you forwarding those logs? If you're forwarding them, are you monitoring that it's still forwarding correctly? There's a lot of configuration errors that can occur maliciously or benignly, but do you understand what those logs look like? Trying to figure out these log options in the middle of an incident is not the time you want to be doing it. Investing that time beforehand will pay dividends, and hopefully you're going to be detecting suspicious activity instead of just investigating something that happened weeks or even months before. And then lastly, Cloud Console Cartographer is the tool we just showed. It is free and open source. And the last slide will have the link to that GitHub there. But again, we had a lot of fun doing this research. We had a lot of fun building the tool and using it internally. And so we hope that you also find it useful. Just, I think 2 weeks ago, we released a blog kind of outlining detail, like step by step, how you can go and add your own mappings and a little more granularity about using some of the functions that we just walked through to add your own mappings to the project. So with that, we just want to say thank you so much for your time. As I mentioned at the beginning, this is a really special conference, and we're really honored to be here. And I've already just been blown away by the presentation so far, and more impressed just with the conversations we've had with several attendees. And so it really is a great opportunity to network and really just share knowledge. And you can find us on LinkedIn and Twitter. We will try to do our best to respond to questions or whatnot, but please feel free to just ask us a question either here or on stage or throughout the rest of the day today and tomorrow. We're always happy to talk, and then there's the link to the project at the bottom. So with that, thank you very much for your time.